In this video, we are going to discuss how to use Kirchhoff junction rule and loop rule to solve problem involving multi-loop circuits. So here we have a multi-loop circuit with resistor R1 equals 5 ohm, R2 equals 10 ohm, R3 equals 15 ohm, VEMF1 10 volt, VEMF2 15 volt, and we need to find the values of current I1, I2, and I3 as indicated in the figure. So before we apply Kirchhoff rules, let us first label the circuit. I will call this as point A, B, C, D, E, and F. So first we will try to find relationship between currents I1, I2, and I3 by applying Kirchhoff junction rule. And we will apply this rule at junction B. So we know from Kirchhoff junction rule that at junction B, sum of all current which are entering the junction must be equal to sum of current which are leaving the junction. So if we look at junction B, the current which are entering is I1 and I2. So we can write I1 plus I2 is equal to the current which is leaving the junction B is I3. So I1 plus I2 equals I3. I will call this as equation 1. After we find relationship between the currents, now we will apply Kirchhoff loop rule. So we will consider the two loops over here. And in order to apply Kirchhoff loop rule, we need to decide the direction of traversing, which is the direction in which we will go around the loop. So I'm going to choose the counterclockwise direction. And whatever direction I choose for the first loop, I have to choose the same direction for the second loop. So how do we apply Kirchhoff loop rule? In Kirchhoff loop rule, when I'm going around the circuit, if I enter negative terminal of the battery, then the potential difference across the battery is taken to be positive. So while going from A to B, if I enter the negative terminal, then I take VEMF1 to be positive. We will write this as positive V1. Whereas if I enter the positive terminal of the battery, then we take the potential to be negative. So while going from B to E, when I'm entering the positive terminal, I will write VEMF2 as negative. For resistors, on the other hand, while going around the circuit, if I'm moving in the same direction as the current, then potential drop across the resistor is taken as negative. So while going from F to A, if I'm going in the same direction as current I1, potential drop across resistor R1 will be negative I1 R1. Whereas if we go opposite to the direction of current, like while going from B to E, if I'm going opposite to current I2, potential drop across R2 will be positive I2 R2. So this is how we will apply Kirchhoff loop rule in both of the loops over here. So let us first start with loop A, B, E, F, and back to A. Now when I'm going from A to B, I'm entering negative terminal of the battery. And if you enter negative terminal, the VEMF here will be positive. So I write V1. Then when I'm going from B to E, I encounter resistor R2. And current in R2 is opposite to my direction of traversing. We are going opposite to I2. So potential drop across R2 will be positive. So we write this as plus I2 R2. Then moving forward, we are entering the positive terminal of the battery. So we take VEMF here as negative. And while going from F to A, we are going in the same direction as current I1. So potential drop across R1 will be negative I1 R1. And all of this will be equal to 0. Now let's substitute the value. V1 is 10 volt, so we write this as 10. R2 is 10 also, so 10 I2. Minus V2 is 15. Minus R1 is 5, so 5 times I1 equals 0. Now let's rearrange the term. We will keep the terms with variables together and the ones with constant will move to the other side. So we get here 10i2 minus 5i1 to be equal to positive 10 when I move to the other side will become negative. Negative 15 when moved to the other side will become positive. So I can rewrite this as minus 5i1 plus 10i2 equals 5. Now, since all of this is a multiple of 5, we will divide by 5 throughout to simplify this. So after dividing with 5, we get minus I1 plus 2I2 equals 1. I will call this equation 2. Next, we apply Kirchhoff loop rule to loop B, C, D, E, and back to B. So while going from B to C and then from C to D, we are going in the same direction as current I3. And if we are going in the same direction, the potential drop across R3 will be negative I3 R3. Then while going from E to B, I am entering negative terminal of the battery. So if you enter negative terminal, the potential difference will be positive, so plus V2. Then while going towards B, we go in the same direction as current I2. So again, potential drop across R2 will be negative I2 R2. And all of this will be equal to 0. Now let's substitute. R3 is 15, so we get negative 15 I3. V2 is also 15 and R2 is 10, so minus 10 I2 equals 0. I3 from equation 1 we know is I1 plus I2. So let's substitute that here. We get negative 15 I1 plus I2 plus 15 minus 10 I2 equals 0. Now multiply this we get as negative 15 I1 negative 15 I2 plus 15 minus 10 I2 equals 0. Now you can keep the terms with variables together and move the constant to the other side. Here I get negative 15 I1 minus 15 I2 and minus 10 I2 together will become minus 25 I2. 15 I will move to the other side and it will become negative 15. Now again each term over here is a multiple of 5, so I can divide by 5 throughout. And since each term contains a negative sign as well, I'm going to divide by negative 5 throughout. So here we get 3I1 plus 5I2 equals 3. And I will call this as equation 3. Now equation 2 and 3 are linear equation with two variables. And we can solve them either simultaneously or using substitution method. You can also directly solve them in your calculator using equation mode. Here I'm going to solve them simultaneously. So what we will do is we will multiply equation 2 with 3 and then add that equation to equation 3. So let's multiply equation 2 with 3. When I do that, I get this as negative 3I1 plus 6I2 equals 3. And then add equation 3 over here. So we get 3I1 plus 5I2 equals 3. Let's add them. Minus 3 plus 3 will give me 0 plus 6 plus 5 will give me 11I2 equals 3 plus 3 will be 6. So we get I2 to be equal to 6 over 11 ampere, or you can write this as 0.545 ampere. Then we can substitute this value of I2 in either equation 2 or 3 to get I1. I'm going to substitute this in equation 2. So equation 2 says negative I1 plus 2I2 equals 1. So I'm going to move I1 over here and bring this positive 1 to the other side. So we get 2I2 minus 1 equals I1, or we can get I1 as 2 times I2. Let's substitute for I2. I will write this as 6 over 11 minus 1. So I1 becomes equal to 12 over 11 minus 1, which is 1 over 11 amperes, or you can write I1 as 0.0909 amperes. Then we find I3 using equation 1. We know I3 is I1 plus I2. Add I1 and I2 to get I3. So we get I1 as 1 over 11, I2 as 6 over 11. So I3 will become 7 over 11 amperes, or you can write I3 as 0.64 amperes. So this is how you can use Kirchhoff junction rule and loop rule to solve problems in multi-loop circuits.